Cool. So, for those who don't know me, I'm a front-end developer. My name's Brad. Obviously, I'm talking about XState. So, XState is a JavaScript state management library. And the way it approaches state management is through finite state machines. If you don't know what that is, hopefully you'll get a better idea through this presentation. So before I get into XState, I just wanted to briefly cover why I adopted it into my stack, because in the front end, it seems like every week there's a new tool that comes out that claims to be better than everything before it. And so when I started in the front end, I bought into this and spent most of my time just learning new tools and swapping out my stack without actually making anything. So what I learned, yeah, people can relate.
No one else has ever done that.
What I learned during this process is a lot of these new tools aren't necessarily better at doing things. They're just different at doing things. And if a tool isn't going to give some kind of significant advantage over something I'm already using, then it's not worth my time learning it in depth and adopting it into my stack. That being said, from my perspective, I think XState does give a significant advantage over the existing state management tools like Redux or React's internal state manager. So I thought the best way to try and explain that is just show how a simple system would be made in Redux and then made in XState. So our system will just have 3 states, step 1, step 2, step 3, and the user can move forwards or backwards through these steps. So they can go from step 1 to step 2 to step 3, and backwards, but you can't skip a step. So this is what the system might look like in Redux. You just have initial state object with a key step and a value of 1. And then you have the reducer that takes in 2 types of actions, next or previous, which increments or decrements the value of step. Okay, so a couple of things I don't like about this is that it seems to encourage you to develop action first. So I first declare my actions and then I create this state object from that, which I find is very difficult. It's like I get a mock-up of a screen from a designer and I have to try and anticipate every little thing that user's going to do and then assign actions to that and then make this state object from that. For me, that's really difficult to do. Also, you don't have named states, you've just got this data object that is your state. So it kind of, you don't plan out your states, you plan out this data object, which kind of tends to lead to state explosion. And this is very difficult to kind of explain your system to someone else as well. Like, you're just saying, look, they can do these actions and it results in this kind of data object. I find that quite difficult to kind of explain. This is what the same system looks like in XState. So, finite state machine lingo, this is a state chart. And the first thing you do here is you declare named states. So you say, the first thing you do is you you define all the states your system can be in. And they've got names, so in this instance, step 1, step 2, step 3. And now within each state, you define what transitions the user can do. So a transition is just an event that changes the state. So in state step 1, the only transition the user can do is next, which would move to step 2. I think that's very powerful because like in Redux, you have actions, but actions can be fired irrelevant of the state. They can be fired whenever. And it comes down to the UI to kind of block actions by disabling buttons or something. So kind of the logic is kind of split between the reducer and in the UI. But here, all the logic is kind of defined here. You have your states, then you have your transitions that change the states. So to me, like in Redux, I felt like I was programming on the back foot because I'm trying to like anticipate all the actions the user's trying to do and write logic around that. But here I'm like, the user's in this state, here's the transitions you can do, no more. So I feel like I'm more on the front foot. Another really good thing about this is you can take this state chart and just dump it in a visualizer and you get this graph. Now, to me, this is a really good way to communicate a system to someone. You have the squares, which are your states, and the arrows are like the transitions of how you get back and forth through states. You can also interact with this. So you can type in an event, which would be a transition, and it'll actually move the state, so you can get a lot of confidence with what you've made before you even move on to implementing a UI. Also super modular as well. You can dump this in a Vue app or an Angular app if you want to go down that route, or React, it doesn't matter, it's still self-contained. I'll just go on to like a more real-world example now, just to cover a few more things about XState. So imagine we've got like a simple email password sign-in form, and it has the states data input, email error, password error, awaiting response, service error, and authenticated. So the state chart was a bit too big to show all at once, so I've just broken it up into parts. Context. So state chart, XState has this thing called context, and it's where you can store data while the user is moving through states. So the email and the password the user enters into the input fields, you can store it in this context object that is in the state chart. Hierarchical states, or states within states. So this gives you more granular control. So I can have the state email error, but within that state, I can have another state, bad format or no account. So what that lets me do is, when I'm rendering my UI, I can test if there's an email error. If there is, cool, I can focus the email input element. But on top of that, I can also check if it's bad format or if it's no account. And based on those two states, I can determine which error message I want to show. There's a thing called guards in XState. So guards let you change state based on a condition. So here we have a transition submit. So when the user hits the submit button, XState will look at this array, go to the first entry, and look at the condition is bad email format, which is just a function. So if that function returns true, we'll transition to the email error.bad format state. If that condition returns false, we'll move to the next one, which is password short. If it returns true, we'll transition to the password error.to short state. If not, we move to the next one, which is pretty handy. XState has a thing called invoke, which takes in a promise and then transitions state depending on how that promise returned its value. So if it was successful, in this instance, it's request sign-in. So this would be our call to our backend service to try and get authentication. If that promise returns successfully, we would transition to a signed-in state. But if that promise failed, then we would return, we would transition to one of the error states, depending on which condition returned true. And I think this is the last one I want to cover is actions. So actions are side effects that you want to trigger when transitioning states. So when I, just say I transition to email error state, a side effect might be that I want to focus that element. I can define that within my state chart so I know that a function focus element will fire when moving into that state. And this is another very cool thing. Your state chart that you define in XState is completely independent from the implementation. So, like I said before, you can put this in any kind of app and the state chart remains the same. So all these like actions, cache email, cache password, or conditions, they're all wired up in a separate object. XState calls this an options object. And so this is where I kind of map my strings to functions or whatnot. So this is where my state chart gets connected to the UI implementation. So if you want more information about this, you can go to my blog. I've done like a breakdown of how I made that sign-in form that kind of explains each step of how to make that in a React environment. And if that isn't enough to sell you, XState is also written towards a W3C specification, so it isn't just some random making it up. And the idea of finite state machines has been around for like a long time, like 30 plus years or something. And like NASA, I think, uses them to like control their rockets and stuff. So it's a thoroughly tried and tested idea for controlling logic. That's me.